Hello everyone, let's try to solve this question from the chapter Current Electricity. Let's go through the question and try to understand what is given in the question. In a meter bridge experimental setup shown in the figure, the null point D is obtained at a distance of 40 cm from end A of the meter bridge. So, as we know that in a meter bridge, resistance ratio, that is R1 by R2, depends on this value of D. That means this ratio R1 by R2 is equal to the ratio of AD by DC, right? So in the first case, since this is a meter bridge, so since the first case says that it is obtained at a distance of 40 centimeter from end A, so this is 40 A to D, and so the D to C is 60. So in the first case, R1 by R2 is equals to 40 upon 60, which is nothing but 2 by 3. So we can say that R2 is equals to 3 by 2 R1. Alright. Now let's read the next line. If a resistance of 10 ohm is connected in series with R1, null point is obtained at AD is equals to 60. That means second case says that the resistance R1 is now changed to R1 plus 10 because since 10 ohm is connected in series. So this resistance divided by the second resistance, this ratio is nothing but again the same AD by DC, and now AD is changed to 60, so DC will be now 40. So this is 3 by 2. So what we obtain that R1 plus 10 upon R2 is equals to 3 by 2. And here we saw that R2 is equals to 3 by 2 R1. So we will replace this R2 by 3 by 2 R1. So R1 plus 10 upon 3 by 2 R1 is equals to 3 by 2. So this gives us 2 R1 plus 20 is equals to 9 by 2 R2, or 4 R1 plus 40 is equals to 9 R1. That means 5 R1 is equals to 40, or R1 is equals to 8 ohm. And we know that R2 is equals to 3 by 2 R1. So R2 is equals to 3 by 2 R1, which is equals to 3 by 2 into 8, which is 12 ohm. So our R2 equals to 12 ohm. So in our question we had to find the values of R1 and R2, and these are the required values of R1 and R2.